Have you ever wanted to build a multi-floor elevator in Minecraft? In this video, I'll be showcasing several variations of my core elevator design, explaining the mechanics, and showing you how to build your own. Walking into this wizard's tower, I'd like to check out the top floor. Unfortunately, there don't seem to be any stairs here. Instead, we'll use this lectern to specify the floor we wish to go to, anywhere from the deep dark all the way to the top. Let's go to the balcony. We'll press the button, and then hop into the elevator shaft, which will fill with water and lift us to the specified floor. Stopping at the balcony, we can grab some fresh air, enjoy the sights, before continuing up to the top. Once again, we select the floor, hit the button, and step into the elevator shaft. From here, we could return to the ground floor, go down to the mines, or step outside for a better perspective. You might be wondering, what is this wizardry? How does this elevator work? To answer that, we need to talk about pulse width modulation. Pulse width modulation, or PWM, is a communications technique used in electrical and power systems, where a signal is represented by a square wave with a variable pulse width, as opposed to FM, where the frequency is modulated, or AM, where, get this, the amplitude is modulated. This will form the basis of how we send signals in the elevator. Schematically, we want to take an analog input, close some sort of gate to briefly pass that input into our PWM converter circuit. And we'll need one of these 3-stage circuits at every floor, and some way to combine from all of these different floors, combine those signals into one global channel that all of the floors can then read from. At each floor, we want some kind of timer to decode the pulse and open or close another gate accordingly to activate or deactivate the floor. Breaking that down into redstone, we input a signal strength using a lectern and comparator, raising a block with a sticky piston to send power through. The PWM conversion uses a comparator fader circuit, so 2 comparators in a loop, connected to a trapdoor. The stronger the input, the longer the trapdoor stays open. To multiplex the floor inputs, we send the signal down using vertical walls connected to the trapdoor, then observe that change at the bottom and toggle the state of a bubble column to send the pulse back up to all floors. To decode the pulse, we observe the bubble column and switch between locking 2 hoppers, using another comparator to read out when one has drained all of its items. With enough time, we lock a repeater to save the floor state until the next pulse starts. Now, before we jump back into Minecraft, I wanted to take a moment to mention that only a small percentage of my viewers are connected with me on LinkedIn. So, if you're not already, go ahead, reach out, let's connect, let's chat. Now back to engineering elevators. So let's take a look at the actual redstone. We have input with a lectern, conversion to PWM with a fader, multiplexing downwards with the walls and upwards with the bubble column. That goes into a timer at every floor with a binary switch that activates the entire floor at once, either dispensing or removing the water. When actually using the elevator, we'll select the floor with the lectern, turning it to the page that corresponds to the floor. Then we hit the button to activate it. And now we can see that one at a time the floors are activating and filling with water, and the water column fills with bubbles. And so that'll take us either up or down if we drop into the shaft to the specified floor. Now that we're familiar with some of the core principles of the elevator function, I want to talk about form factor. So the very core elevator shaft, right? None of the circuitry on the sides, just transmitting information up and down, takes up a 3x5 space. And I think this is about as small as it can get. So we require 2 water columns, one to carry the player up and one to transmit information up. We also require 2 wall channels that each carry information down either globally or locally. The walls require having blocks on both sides so that they extend into this longer variant. And the water requires a retention system, so that's 4 blocks on each side. That leaves us with these 2 blocks, which are not strictly necessary. We can leave those open, but that doesn't really change the footprint overall. So that's about as small as we can make the core elevator. And then for the base design, I think this is roughly the smallest we can get the floor electronics without sacrificing our 3-block tileable vertical distance. You'll notice here that you just have 2 air blocks before the next floor starts. And that's about as small as I think you'd have in any Minecraft build. There's 2 blocks that extend behind and 2 blocks that extend to the sides, extending the overall profile to 5x7 with a couple of air blocks that are not necessary. One of the things that some people want to do is incorporate this into a larger build where it's flush with the back. So for example, a skyscraper where you want to have solid blocks right at the back and then your elevator as close to that rear wall as possible. We can do that by rotating the floor circuits to the side in both cases. So rather than keeping them here and then overlaying them over each other, we shove them into and between the side walls. So you'll notice here that the entire circuitry can now fit flush between your rear wall, 2 block space, and then a front wall. And this extends to the sides. It does get a lot wider, but that's a sacrifice we're willing to make. If we actually look at what's going on here, you'll notice these 2 blocks do stick out, but those will be covered every time that we have a floor come out, right? So this is not actually going to affect your elevator, right? That's all going to be wall anyways. And so let's talk about what's actually going on in here, how we're able to shift it around. This fader circuit has been rotated by 90 degrees. And so you'll notice that when this powers, it just loops around here. And the reason we've shifted this comparator down and this redstone dust down is because we don't want to have this block being raised power the trapdoor directly. The reason we want to avoid that is to keep these timings compatible with those timings. So you could actually, I'll have schematics in the description and world downloads. You can mix and match between these floor designs and those floor designs, and the timings will be all the same. And that's because every time that this decrements, right, we still 2 gain ticks of delay for 1 decrease in signal strength, and we make sure that the input is just as long. If this block powered the trapdoor directly, if we had it say here and shifted these back up, then the problem is that it'll stay on for the extra amount of time that this piston spends before the signal has time looping around over here. And so we get a slightly longer delay, which is fine. You can have that if you're just doing this style of elevator, you can skip this like shift down and make it a little bit easier to build, but then it won't be compatible with those timings, as in when you input it's 5, it'll be a slightly longer pulse than if you input a 5 on that timer. On the other side, we do something that is a little wonky, but so we need to be observing the bubble column in here, right? And that's normally done in the back, right? We have these observers here that fire into the pistons, and then those will actually power the hopper timers and lock each floor. Instead, what we do is we rotate that over to the side and fit it in between each of the walls for like a floor set. So if we look over here, we'll notice that we're already splitting the walls every time that there's a floor change. And so we simply reuse that block to drop an observer in and then a trapdoor below it. So these observers will, again, go into basically an identical circuit that we had over there in the core elevator. Right? We have a piston that swaps between locking 2 different hoppers. So its default state is locking this one that we're reading out from, and then when it switches over, this is going to extend, unlock this hopper, items will flood out, and when it runs out, it's still doing the same thing. One other difference is we have to reorient the signal back to the wall, and so we do that with this note block here that will be silent because it's got something on top of it. So as long as this block here exists, right, so if you have some sort of full block or slab or whatever, then the note blocks aren't going to make annoying dings. That's I think it for this form factor. One other thing that I want to talk about is speed. So if we step into this elevator and go up to the 14th floor, one area where it struggles is for small changes at high floors. So it doesn't matter how tall the floors individually are. When you get to the 14th floor, it's the same amount of time to activate to that point. But if we wanted to go up 1, so from the 14th to the 15th, we'll notice that it first empties out, and then we sit here and wait. And only then does it take us to the top. And it's fine, I guess, but we can go faster. One of the things that we'll notice is this circuit here is on for the minimum, the amount of time it takes for this button to depress, which is 10 redstone ticks in the for stone buttons. And that's all wasted time. If we could activate this for fewer ticks, right, just the minimum to get the pulse going in this timer and then break the pulse with this piston, that would be potentially 5-6 redstone ticks saved every single time that we activate a floor. And so that's exactly what we do over here. We take our first input pulse to toggle this block to the top, and then just chain some observers around to fire this piston a second time. So the top floor here I have built out to the side to make it easier to see what's going on, but for lower floors, I suppose I can destroy this. We'll see that it takes the output of this, and we add 1, 2, 3, 4 observers firing around in a chain here to keep it tileable and not take up any extra space. So that's already one improvement, is if I was to fire this, actually let's see how much longer this takes. If I wanted to have the water come up to the 15th floor, from when I activate this, we'll see it empties, and then it's up to the top. You might have noticed that that ran a little bit faster. So the floor activation itself, we've managed to double the speed. And the way that we do that is by changing the fader circuit to be different as well. So let's take a look at what's going on here. In a normal fader circuit, we decrement the pulse once every 2 game ticks, or 2 redstone ticks, sorry. So each comparator adds 1 redstone tick of delay, and then we step down by 1 pulse strength. And so the disadvantage here is that we spend half the time just waiting for the pulse to get here and update. So naively, what we could do is, instead of stepping down once, we could step down twice. And while this clock will only last half the time, right? So if I grab like a redstone block from, there's so many red things. So if I set this input here, you'll notice that only stays on for half the amount of time compared to something like this, where we power it and then it fades much slower. But the problem is we carry half the resolution. So every time that this decrements, if you notice up here, it's going to say power 0 in the top right. For this version, it's up to 15, and then it decrements by 2. So it goes 15, 13, 11, all the way down to 1. And so we're only able to store half the number of floors. And the problem is, at that point, we might as well just use this and have every other floor be, or just put in half the number of floors, because it still takes 2 redstone ticks to do 1 cycle. So what we need is some way to keep this circuit here, but check multiple times per cycle to see if the signals run out. And the way that we achieve that is by having the odd and even signal strengths power the trapdoor at the same time. So if we input in even signal strength, let's say 4, it starts at 4 here, drops down to 3, then gets repeated to 3, drops down to 2, then drops down to 1, and then drops down to 0. So we'll notice that the odd pulse, or the odd signal strength at 1 is the last one powering this trapdoor. If we instead input an odd signal strength, so let's say we input 3, it steps down to 2, gets repeated to 2, which is powering it. So this is an even number instead of an odd one, steps down to 1, and then steps down to 0. So we'll notice that this block right here, which is receiving signal strength 1 from this bottom comparator, is redirected into this target, and that's still powering this trapdoor. So if we input an even or an odd signal strength, the opposite side of this will be the last block to power this trapdoor. And so even though each cycle takes the same amount of time, 2 redstone ticks, we check twice per cycle, once for odd numbers and once for even numbers. And that allows us to double the speed. One other thing that we need to do then, let me fire this back down to close this. So we also need to check at 4 times hopper speed on this output, right? So previously we checked double hopper speed by locking this repeater at either 1 or 3. Now we need to do it at 1, 2, 3, or 4, but otherwise it's the same. So you'll notice down at the bottom, the timings for the bottom circuit are also different because we're now inputting a shorter pulse. So the first hopper only holds 3 items and it is on a redstone tick delay of 3. And then we just increase by 1 tick per floor. So it goes from 3 to 4 ticks of delay, and then it'll loop back to 1, and this will go up from 3 to 4 items. So now we have 4 items and 1 tick of delay. Then 4 and 2, 4 and 3, 4 and 4, and that continues all the way up. And so the end result is something that's really quite fast. If we want to go to the 3rd floor from the 8th, we'll hit this button, it'll empty, and it's already full. I could have jumped down earlier. If we want to go from the 3rd up to the 13th, right? I step in, this will empty, and it's off. So this is about as fast as I think it can be made. Technically, I think there's 1 redstone tick of delay that we could potentially save if we were to shift the circuit out here. You'll notice that there's this extra comparator here that takes a little bit longer to activate this initial channel, but that's done for the sake of compactness. So I know we said we're going for maximum speed here, but this is still relatively compact, so it takes up an extra block on the sides and has a slightly longer or like larger overall profile, but it doubles the speed in nearly all cases. One other area where we could potentially, again, increase the size and then increase the speed is if we had 2 water columns that carry information. And that's because the input and output delays for switching this from soul sand to an empty block are different. So one of them's faster than the other, and so we could have 2 water channels where we read from the input on one and then the output from the other. But at that point, we're starting to increase the complexity to a point where we might as well just have separate channels for communicating to each floor and then have no delay, and then we're back at like a standard elevator design that's super wide and bulky and hard to integrate into a build. So that's about that. I guess one other thing that I could show off is how to make it Nether compatible. So water obviously doesn't flow in the Nether, and so we have to make a couple of sacrifices. We can't use the bubble column in the back for vertical communication, and so we'll use scaffolding that toggles with a trapdoor here that's going to switch the state of the scaffolding from being supported to unsupported. And so if I wanted to go up to, I don't know, the 3rd floor, we just hit this button and we'll notice that this will flood. And so you can step in and you're off. It's a little bit slower than the normal elevator, but hey, I mean, it works in the Nether, and it still has 15 floor capacity. So we could drop down back to the 2nd floor maybe. Hit this button and it'll again empty this out. We can hop down and we're at our...
Does this work?
Does
in
it
Bedrock?
work in Bedrock?
I don't know if
I mean,
you mentioned
Bedrock.
this is Bedrock. I
They're
only
always
made
made it work.
Bedrock Edition.
We're limited to just 8 floors because lecterns in Bedrock are stupid. I'm on page 1, I'm gonna click +1 page, and now the signal strength is 3. I click +1 page again, and now we're on signal strength 5. So we can only do odd numbered floors, 1, 3, 5, 11, etc. Okay, I'm just kidding, it doesn't have to be odd numbers, it'll just take, we only have 8 possible floors. The pistons in Bedrock don't spit out their blocks on a single tick pulse. So when I fire this with an observer, it does not drop the block. This is going to break 3 different parts of the elevator: the inputs, the soul sand swap at the bottom, and the timer readouts. Walls do not transmit their signals instantaneously downwards. So when I toggle this, you'll notice it takes a tick of delay for every block. That's fine, it'll just make the elevator slower. Upwards transmission using soul sand is worse on the way up because it takes 1 tick instead of being instant, and on the way down it's much worse. It takes, I don't know how long that is, but this is going to have to change for communication upwards and downwards. We can't be waiting for this to transmit signals up and down every time. Okay, and then dispensing water. This should just be fine. We dispense water and we have a bubble elevator. That's good, thank goodness. That all works as normal, and it was very fast. What? There's still water in these dispensers, and no bubbles and water above the soul sand. We can bring it back, and it's still gone. What? What is it? What? Huh? Okay, we're going to have to make some pretty significant changes if we want this elevator to even have a semblance of working. Okay, we had to make several changes to get this to work in Bedrock, starting with the input. The observer is replaced with a torch inverter, so when you press this button, it'll raise this block and then drop it, which fixes the issue with pistons not dropping their blocks on 1-tick pulses. The fader circuit is rotated out 90 degrees. That's to avoid some intersections with the floor decoding circuits. And for now, I'm leaving it as a 1 redstone signal drop per cycle. Even though that causes the elevator to be slower, it's already slow in Bedrock because of the timings per floor, so a little bit extra doesn't hurt that much. If you're clever, you can probably figure out a way to have it drop by 2 every cycle and then change the timings yourself. But to quote my textbooks, the problem is trivial and left to the viewer as an exercise. On the ground floor, where we want to send the signal back up to the top, we're actually no longer using soul sand, and we're instead using scaffolding, because soul sand, as you noticed in our testing, is not consistent for up and down. It takes much longer on the up direction, and so we don't want to have to wait that long. Instead, we use scaffolding here that gets toggled with a trapdoor, and we have to use a T flip-flop for that. So on the first pulse, this dispenser is going to drop an item into the lower dispenser with this hopper, and then, or sorry, dropper, whatever, not dispenser. And then on the second pulse, it's going to get pushed back up into here. And so I tried using the same design for a T flip-flop on each floor to toggle the piston states, but for some reason, I know Bedrock is not supposed to have any like QC or bud powering, and yet some of the floors would not work. So I'm just gonna chalk that up to another episode of Bug Rock. Within each floor, we have to do quite a bit more, so it gets a little bit less compact, but it still fits within sort of the original footprint. Not really, no. Well, if you want a smaller elevator, just don't play on Bedrock. So what we do here is we take that output from, actually let's go to the top floor and look at what's going on here. So we take the output from the scaffolding tower and we activate a T flip-flop, which is really just this copper bulb that switches from on to off, and we read out from electric. We do two things. The main thing is we're going to switch which hopper is locked, same as normal, so we still read out from that hopper with a comparator, and we still take the redstone power into a repeater, and we still lock the output of the repeater going into the trapdoor. So that's all as normal. And then the secondary circuit over here is a falling edge detector. So when this receives its second pulse, right, so when this turns off, this one will extend back out, right? On, it comes over here, the observer fires into nothing, and then off, it fires into this line of dust. And then that goes into a 4-tick repeater. It's going to power just the top dispenser of every floor. And that fixes this stupid bug where, I think it's gotta be a bug, where you have water that's not existent. So there's still water in here. I found a log of it for Pocket Edition, and this seems to be on all versions of Bedrock, but this is just stupid. And then you sometimes get floating water sources. I don't know. You saw it earlier. It's not consistent, actually. So that just sucks. So instead what we do is, after the elevators run its course, we just power the top dispenser on and off for each floor. So if I wanted to go up to the third floor, which is 5 in there, that's whatever. Then it's going to run for a bit, and then we can see that all of them fired. There's a little bit of water that comes through, and now we're at first, second, third floor. If I wanted to instead go to the next floor, so 4th, we'll see this will empty out partially. It'll leave this, and then at the end that gets fixed when this does this whole cycle, and then we have bubbles up to the top. If we're going to go from there down to this, let's do 2nd floor. So we should now have water to here. We'll see it all empties out, and then those all get fired, and after a little bit of time, everything resettles, and we're at this floor. So it's buggy, it's slow, but at least it's consistent. You can still go from any floor to any other floor. So all of these, you just repeat the circuit going up. It's still tileable every 3 floors, or every 3 blocks, so you can still have a relatively compact elevator. And then the core shaft is the same size. So realistically, in any build, this is the thing that you want to hide, right? This 3x5 area, and that's still the same size. It's just the floors are a little bit larger. So there you go. That's it in Bedrock. Don't ask me to do that again. All right, one more thing before I wrap this video up. I'm gonna walk you through how to build custom schematics using the files I have linked in the description to make your own custom elevators with custom floor placements. I'm using the Lightmatic mod, which I am by no means an expert in, but I can bumble through it enough to show you guys how I do it. So we're gonna hit the M menu to open this guy here, and then load in 2 schematics. We're going to use the simple elevator core. So load the schematic, and then the simple floor final. Load the schematic. The elevator core is going to create this main elevator shaft, as well as the circuitry for the bottom floor. You can select with middle click, and then, hold on, let me switch this to schematic placement, sorry. So you can select with middle click, and then Alt scroll to move it around. So we can place our core wherever we want. And you'll notice it already has the timer for the first floor with the trapdoors and everything. These blocks on the sides, again, they can be whatever. Reference my previous video, but that's all customizable. We position this wherever we want. If we want to rotate it, we'll go M again, and then in the schematic placements, we'll hit configure for this active one here, this simple elevator core. We'll configure, and we can rotate it around, flip it, in different directions. It'll work in all orientations. So once we're happy with how we want this to be placed, we're going to select the floor, and then again with Alt scroll, move it over to position. And the important thing is we want this lectern to line up vertically with where we're going to be putting that first lectern. And then as long as the spacing in between is a minimum 3, so this is as close as you can pack them together, but then you can space these floors as tightly as you want or as loosely. So maybe we would want one here. And actually, so the way that I would do this is I'm going to change my mode with Control scroll to paste schematic into world, select the main core, and hit whatever shortcut. I think I have K for pasting it in. Now I can switch over to the other selection, again with middle click, and paste them one at a time. So I'll paste this floor in, then Alt and scroll. Maybe we have another floor here, and then there's another floor there, and another one there, and another one there. Okay, there we go. There's our elevator. Let me move this really quickly out. Hold on, with schematic placement and Alt scroll. Okay, so here's where we have our core elevator. We can move more of them to be elsewhere. And then there's 2 more things that need to change, or if you're building it as you go up, then you can do this as you do that. We need to replace to have only observers on every 3rd block. So this middle section here, this observer obviously doesn't do anything, he's just watching the wall. But then beyond that, we also want to have it so the lowest observer for any given floor fires down to this one. So we would replace this guy right here with a block, right? So notice that this is now firing these 3, and then we don't want this one to double fire over here. So we'll replace this with a solid block. And then from there, you just need it to be at least every 3rd. So this is fine. These 3 will fire up to here, and that's totally okay. And down to here, you could replace the middle one and just keep the outer 2, and then same for the other floors, right? So at every floor, you'll want to replace this, these observers, and at every floor, we also want to make sure the timers are set up correctly. So in my previous video, and I think earlier today, I talk about what the timings look like for the fast elevator and the simple elevator. So we'll need to change these hopper timers, or the hoppers and the repeaters from 1 and 3 ticks accordingly. That's it for this. Then you should have a functional simple elevator. If we want to do the faster version, or the shallow one is identical to this, the faster one is also very similar, so I'll walk through that one as well if you want to watch that. If not, just you're welcome to stick around. Thanks for watching, I guess. So let's again go to our schematic placements with M. We'll go to loaded schematics, and then let me unload all of these, and instead load 2 new ones. We're going to take this where's fast core? Fast elevator core, we're going to load that, and fast floor, we're going to load that. So the fast elevator core, oops, okay, ignore the fact that it has these blocks down there. Those are not necessary. We'll drop that wherever we want. Again, same thing where we can rotate this around. These are almost the same. The difference is the fast elevator has the downwards multiplexer in the back, where the simple one has them on the sides. Same thing for the shallow. So simple and shallow use the same core. Fast one uses a different one. And again, it has the input timer down at the bottom. And then once we're happy with this position, we can, again, paste this schematic in the world. And let me select this and move it over. We can again rotate them, but these are by default aligned together, but in opposite directions. So it'll be very clearly obvious that if I, for example, wanted to paste the fast elevator section into the fast floor, you can't really screw these up because the lectern doesn't face the same way. But you can rotate them to face the same way. This is just for idiot proofing. So if I position this over here, we want to just make sure that the 2, what's it called? Fence gates intersect with this row of blocks here in the front, and so we could lower it, again, minimum 3 block space. So this is the closest it can go, right, where you have 3 blocks and then 3 blocks again. So you can K to paste, move this higher up, put another floor there, and then another floor up there, and again, extend the middle section if you need to. And then we move this out of the way. And again, we'll have to specify the hopper timers and the observers for each floor. That's all very doable. I think that's it. Yeah. one thing to note is that you'll need to make these books with 15 pages for every floor. Even if you have less than 15, the signal strengths are only consistent 1 to 15 if you have at least, well, exactly 15 pages. And then something that I like to do is for filling these dispensers with water buckets, because it is a pain to do that normally, is fill them with empty plain buckets, not water buckets, because you can carry those in stacks of 16. And then you can flood this entire chamber with kelp. And then before you activate it, you just need to fire the dispensers all once, which you can do just by toggling the top wall before you set up floor separators. So before you place these observers breaking this connection, you can just fire everything from the top and it'll collect all of the water, and then you have a full stack of dispensers. I think that's it. I think that's everything. Yes. Okay, well, thank you to everyone for sticking around, and oh my gosh, thank you for all of the extremely positive feedback. This has been absolutely crazy. I did not expect things to go well. Yeah, so really, really heartfelt thank you from me to everyone. I'm a little sleep deprived right now, so ignore my rambling. But this has been a really fun experience. I look forward to making more Redstone engineering content. Please let me know if there's things that you want me to talk about. I had a couple of ideas that I wanted to look into. There's like a recording studio that I think would be cool to build, where you can record custom loops of like you playing note blocks and then have that get saved and played back to you. I think that could be really cool. A lot of people have been commenting about the ghast elevators, which I am completely unfamiliar with. So I need to check out the latest version with happy ghasts and see if we can incorporate that here. I know there's some people that have been doing thinking on incorporating this with like flying machine elevators and just using this main channel for calling the thing from floor to floor. That's a really cool application. If you want me to showcase your builds, which I know I'm not a big YouTuber, but I guess I am now or something, don't hesitate to ping me, reach out to me, hit me up in the comments, or I don't know, we can connect via email or Discord or something. But I would love to showcase builds that you guys put these in. And of course, shout out your channels, because I think there's so many cool people out here. People are making really cool stuff. I want to make the community better, and I want you guys to help me get better. So if you have suggestions on like what was good or bad about the videos themselves as well, I'm not an expert at video recording. I'm just hacking stuff together with OBS, but please give me your feedback, your comments, your criticisms. Everything's appreciated. We're here to be better.